Let's take a look at various components of the ellipse. Let's take a look at a couple pieces to our ellipse. Let's pretend this ellipse is centered at the origin, and we're going to be taking a look at a couple vertices. I am calling them V1 and V2, and they're going to lie along my x-axis for right now. I have two other points that are called foci, so F1 and F2 would be my foci of this ellipse. And when you have this case where your vertices, your foci, and your center all lie along the same axis, then that's known as your major axis. It's going to end up being the longer of the two with regard to your ellipse. So think of ellipses as squished circles. This one's going to be longer horizontally than it would be vertically. I'm also going to be taking a look at two other points. I'm going to call them P1 and P2. Those are going to lie along my minor axis, which in this case my y-axis, or my vertical axis would be my minor axis. It's going to be shorter than the bigger one. And your ellipses are created by these two foci. Kind of think of them as thumbtacks or nails, and you have a piece of string. If I put a thumbtack here at this first and second foci, and I connect a string between those, and then take my pen, that's going to be the part that helps me create my ellipse. So let's start talking about our general formula for an ellipse. We're going to start with this one, which is x minus h, the quantity squared, over a squared, plus y minus k, the quantity squared, over b squared, equals 1. Now let's talk about a couple pieces you're going to want to make sure you're aware of. Our a value in this case is going to be something bigger than our b value, and both of those numbers are going to be bigger than 0. Since a is our biggest value here, this a squared term is going to be right now under the x term. That's going to be an indication that your ellipse is going to have a major axis that is horizontal or along the x-axis if you had an ellipse that was centered at the origin. Now this equation is also assuming that your center for the ellipse is at the point HK. If our center is at the origin, then these h and k values would be 0, and we could simplify our equation a little bit more. If that was the case, then our equation would simplify to x squared over a squared plus y squared over b squared equals 1. Now let's talk about a couple other pieces you're going to want to be aware of. A is going to represent your distance from the center out to your vertices, your V1 and your V2. Your B value is going to represent your distance from the center out to a point on your minor axis. And your C value is going to represent your distance from the center to your foci. Keep in mind your foci are going to be on the inside portion of your ellipse. That probably means you'll want to keep this formula also handy. C squared equals a squared minus b squared. So you're going to be subtracting these two pieces and then taking the square root to get your c value. Keep in mind your a squared term is the bigger one in this case, so obviously your a squared term should come first here.